Section 20 of All About Coffee. This is a Librivox recording. All Librivox recordings are in the public domain. For more information or to volunteer, please visit librivox.org. All About Coffee by William Ukers. Chapter 16. The Microscopy of the Coffee Fruit. The microscopy of the coffee fruit. How the beans may be examined under the microscope, and what is revealed: structure of the berry, the green and the roasted bean, the coffee leaf disease under the microscope, value of microscopic analysis in detecting adulteration. The microscopy of coffee is, on the whole, more important to the planter than to the consumer and the dealer, while on the other hand, the microscopy is of paramount importance to the consumer and the dealer as furnishing the best means of determining whether the product offered is adulterated or not. Also, from this standpoint, the microscopy of the plant is less important than that of the bean. The fruit and the bean. The fruit, as stated in Chapter 15, consists of two parts, each one containing a single seed or bean. These beans are flattened laterally so as to fit together, except in the following instances. In the pea berry, where one of the ovules never develops, the single ovule having no pressure upon it is spherical. In the rare instances where three seeds are found, the grains are angular. The coffee bean, with which the consumer is familiar, is only a small part of the fruit. The fruit, which is the size of a small cherry, has, like the cherry, an outer fleshy portion called the pericarp. Beneath this is a part like tissue paper, spoken of technically as the parchment, but known scientifically as the endocarp. Next in position to this, and covering the seed, is the so-called spermoderm, which means the seed skin, referred to in the trade as the silver skin. Small portions of this silver skin are always to be found in the cleft of the coffee bean. The coffee bean is the embryo and its food supply. The embryo is that part of the seed which, when supplied with food and moisture, develops into a new plant. The embryo of the coffee is very minute, and the greater part of the seed is taken up by the food supply, consisting of hard and soft endosperm. The minute embryo consists of two small thick leaves, the cotyledons, a short stem, invisible in the undissected embryo, and the small root, the radicle. Fruit structure. In order to examine the structure of these layers of the fruit under the microscope, it is necessary to use the pericarp dry, as it is not easily obtainable in its natural condition. If desired, an alcoholic specimen may be used, but it has been found that the dry method gives more satisfactory results. The dried pericarp is about 0.5 millimeters thick. Great difficulty is experienced in cutting microtome sections of pericarp when the specimen is embedded in paraffin, because the outer layers are soft and the endocarp is hard, and the two parts of the section separate at this point. To overcome this, the sections might also be embedded in celloidin. When the sections are satisfactory, they may be stained with any of the double stains ordinarily used in the study of plant histology. A section cut crosswise through the entire fruit would present the appearance shown in Figure 333. The cells of the epicarp are broad and polygonal, sometimes regularly four-sided, about 15 to 35 mu broad. At intervals along the surface of the epicarp are stomata, or breathing pores, surrounded by guard cells. The next layer of the pericarp is the mesocarp, the cells of which are larger and more regular in outline than the epicarp. The cells of the mesocarp become as large as 100 mu broad, but in the inner parts of the layer, they become very much flattened. Fibrovascular bundles are scattered through the compressed cells of the mesocarp. The cell walls are thick and large, amorphous. Brown masses are found within the cell. Occasionally, large crystals are found in the outer part of the layer. The fibrovascular bundles consist mainly of bast and wood fibers and vessels. The bast fibers are as large as 1 millimeter long and 25 mu broad, with thick walls and very small lumina. Spiral and pitted vessels are also present. The layer next to this is a soft tissue, parenchyma. The parenchyma, or palisade cells as they are called, is a thin-walled tissue in which the cells are elongated, from which fact they receive their name. The walls of these cells, though very thin, are mucilaginous and capable of taking up large amounts of water. They stain well with the aniline stains. The endocarp is closely connected with the palisade layer and has thin-walled cells that closely resemble in all respects the endocarp of the apple. The outer layer consists of thick-walled fibers, which are remarkably porous, while the fibers of the inner layer are thin-walled and run in the transverse direction. The bean structure. Spermoderm, or silver skin, is not difficult to secure for microscopic analysis because shreds of it remain in the grove of the berry, and these shreds are ample for examination. It can readily be removed without tearing if soaked in water for a few hours. The spermoderm is thin enough not to need sectioning. It consists of two elements, sclerenchyma and parenchyma cells. Sclerenchyma forms an uninterrupted covering in the early stages of the seed, but as the seed develops, surrounding tissues grow more rapidly than the sclerenchyma, and the cells are pushed apart and scattered. The cells occurring in the cleft of the berry are straight, narrow, and long, becoming as long as 1 millimeter, and resemble bast fibers somewhat. On the surface of the berry, and sometimes in the cleft, there are found smaller, thicker cells, which are irregular in outline, club-shaped, and vermiform types predominating. Parenchyma cells form the remainder of the spermoderm, and these are partially obliterated so that the structure is not easily seen, appearing almost like a solid membrane. The raphe runs through the parenchyma found in the cleft of the berry. The endosperm consists of small cells in the outer part and large cells frequently as thick as 100 mu in the inner part. The cell walls are thickened and knotted. Certain of the inner cells have mucilaginous walls, which when treated with water disappear, leaving only the middle lamellae, which gives the section a peculiar appearance. The cells contain no starch, the reserve food supply being stored cellulose, protein, and aleurone grains. Various investigators report the presence of sugar, tannin, iron, salts, and caffeine. The embryo may be obtained by soaking the bean in water for several hours, cutting through the cleft, and carefully breaking apart the endosperm. If it is now soaked in diluted alkali, the embryo protrudes through the lower end of the endosperm. It is then cleared in alkali or in chloral hydrate. The cotyledons shown have 3 pairs of veins, which are slightly netted. The radicle is blunt and is about 3/4 millimeters in length, while the cotyledons are 0.5 millimeters long. The coffee leaf disease. The coffee tree has many pests and diseases, but the disease most feared by planters is that generally referred to as the coffee leaf disease, and by this is meant the fungoid Hemileia vastatrix, which, as told in Chapter 15, destroyed Ceylon's once prosperous coffee industry, as it has since been found in nearly all coffee-producing countries. It has become a nightmare in the dreams of all coffee planters. The microscope shows how the spores of this dreaded fungus, carried by winds upon a leaf of the coffee tree, proceed to germinate at the expense of the leaf, robbing it of its nourishment and causing it to droop and to die. A mixture of powdered lime and sulfur has been found to be an effective germicide if used in time and diligently applied. Value of microscopic analysis. The value of microscopic analysis of coffee may not be apparent at first sight, but when one realizes that in many cases the microscopic examination is the only way to detect adulteration in coffee, its importance at once becomes apparent. In many instances, the chemical analysis fails to get at the root of the trouble, and then the only method to which the tester has recourse is the examination of the suspected material under the scope. The mixing of chicory with coffee has in the past been one of the commonest forms of adulteration. The microscopic examination in this connection is the most reliable. The coffee grain will have the appearance already described. Microscopically, chicory shows numerous thin-walled parenchymatous cells, lactiferous vessels, and sieve tubes with transverse plates. There are also present large vessels with huge, well-defined pits. Roasted date stones have been used as adulterants, and these can be detected quite readily with the aid of the microscope, as they have a very characteristic microscopic appearance. The epidermal cells are almost oblong, while the parenchymatous cells are large, irregular, and contain large quantities of tannin. Adulteration and adulterants are considered more fully in Chapter 17. End of Section 20, recorded by Marcel Quay.